Hi, good morning, everybody. So, today is the second video we are going to make about the class 9 mathematics. Uh, the main things that we have learnt in the previous class are natural numbers, whole numbers, integers, and we have learnt about rational numbers. Today we are going to learn a little more about rational numbers, and we are going to learn about irrational numbers. And along with irrational numbers, there is one more thing we need to learn about in this entire number system concept, that is called the real numbers. So these are the things that we have already learned so far, and these are the things we need to learn more, and certain applications of all these things. Now I was actually going through the syllabus of ICSC, and after studying the 8th, ninth, and the 10th syllabus of both CBSE and ICSE, I realized that there is a disparity in the standard wise or class wise systems. What are there in the 8th standard in class 8 and of CBSE and ICSE are quite different. Class 9 are also quite different. 10 are also a little different. But when you add them up in the 8th, ninth, and the 10th standard in both the boards, you learn the same thing. So with what I was actually thinking, that in the class wise model, the students of both the board can benefit. I think that will not be possible. Maybe I would not say impossible. It is rather more difficult. What I am thinking is that the current videos of this particular series we will make keeping on the CBSE syllabus in mind. Right now I'm making the 9th standard or the 9th class videos. Then I'll make the 10th class videos, and then again I'll make the 8th class videos. So 8th, ninth, and 10th, all of them will be there. And thereafter, I'll make the same things for the ICSE. Okay, so that is the most important thing we want to discuss before we start this particular thing. So now, let us get to the most important part of the course, that is our decimal representation of rational numbers. So if there is any rational number, say p by q, such that p and q, these are all belong to integers, some integer, and q not equal to 0. Okay, so this is our definition of a rational number. We also assume that p and q are in their simplest form, so we can say that HCF of p and q equals to 1. So under these circumstances, what we basically put is that if we actually divide p by q in a proper way, so we keep on doing this, so what we get at the end is a remainder, and what we get here is called the quotient, right? So if at certain point we see that the remainder becomes 0, and then the net quotient is what we call is the final quotient that we get, that is called the representation of p by q in decimal form. Okay, so let's check by an example. Say there is a number like 5 by 8. So if we actually divide 5 by 8, what do we get? Since 5 is smaller than 8, so we have to point a 0, first place a 0. So this becomes 50. So then we put here 6. So this becomes 6 8s are 48. So we get 2, because we have put a point, so automatically the 0 comes. So there becomes 2. So this becomes 16. This becomes 4, which means this becomes 40. So you see the remainder is 0. So which means this one is the decimal representation of 5 by 8. That is 5 by 8 equals to 0.625. Okay. So this is what we call is the decimal representation of 5 by 8. Now if you see very, you observe this. I'm giving you one more example of this particular thing. So let me give you another example. Say 3 by 4. So if we divide this by 3 by 4, so 3 ones are, sorry, absolutely the opposite one I did. 3 is the dividend, 4 is the divisor. Okay, so 0, this is 30, 4 sevens are 28, 4 sevens are 28, we have got 2, 0. So this is 5, this is, okay, so you see this is the okay. So if you actually observe that if you are having a rational number in the form of p by q, if this particular thing q is a multiple of 2 or a multiple of 5, I mean not exactly multiple, I mean, we basically say that is something of the form of 2 to the power m into 5 to the power n. So the prime factors of q, if the prime factors of this denominator is either 2 or 5, only then we will basically find that our division ends at a particular number where this remainder becomes 0. Okay, so this is a very important thing. Okay, so this particular thing that we are discussing here is a very important thing. This we will understand when we go to the next example. Say we now have to do something about 2 by 3. So say there is a rational number q which is in the form of 2 by 3 and we need to represent it in a decimal form. So let us divide 2 by 3. So what do we get? We get 20. So what we get here, you tell me. So 3 6 are 18. What we get is again a 2. So 18. Again a 2. 18. So we will always keep getting 2. And this will keep on going. So this which means what? This decimal is this division activity is not terminating. When a division is not terminating, it is just repeating itself, then it is called a non-terminating repeating decimal or a recurring decimal. So how do we represent that? We represent that in the form of 0.6 bar. So this bar means whichever is the set of repeating number, we put a bar on that. Now it is not necessary that we will have only one number which is repeating. For example, if we take this example, say by anything by 7. Say for example, we divide 5 by 7. Let us see what comes out of 5 by 7. So we have 5 and we have 7 here. So 0.50. 7 sevens are 49, right? So we have 1, 0. 7 ones are 7. Then we have 3, 0. So 7 fours are 28. Okay. So after 28 we have 2 0. 2 0 means 2 14 6 0. This is 8 56 4 0. Then we have 7 5s are 35. We again have 5, which is 0. So see, after that if we keep on going, we will keep getting the same things, because we have actually reached where? We have reached the place where we started. Okay. So once we have reached the same place, which means if I keep going on by the process, this whole entire thing will keep repeating itself. It will come 7 1 4 2 8 5. Again 7 1 4 2 8 5. So how do I then actually represent this? I represent this by 0.7. I represent this by 7 1 4 2 8 5 bar. So you got this particular thing. So if you actually observe, if the number, whatever be the q, okay, so so the expansion of anything which is say this is n number of whatever be the number here in the form of q, the total number of repeating maximum numbers that can be there in this in the decimal form which are repeating is n minus 1. So that is 6 here in this particular case. So this is called that, this particular thing is called the length of the period, and it is said that, one second, I'm just taking a thing from my notes. Yeah, so if the divisor is basically n, then the maximum number of entries in the repeating block of digits, maximum number of entries is n minus 1. Okay, and this is called the length of the period. So this is what we have to understand. So now we will go to the other side. I mean, say for example, we have a rational number in the decimal form. Okay, so and we have to convert it into normal normal p by q individual format. Say we have to do that. So how will we do that? So for that, say for example, we have been given that represent q equals to 1.4 bar in a p by q form. So how do I do that? So the best way to do that is, see, this is how we normally do it. So if you see there is a bar above 4, so what we first do is multiply by 10 q. So this will be 14.4 bar. Now we write again the original q, that is 1.4 bar. Now if we subtract these two from both sides, what do we get? We get 9q equals to 13, right? Because this 4 and 4 goes away, and 14 minus 1, 13. So q becomes 13 by 9. So now you got how we get it. So this is where, if we generalize this entire thing in a manner that, say we have a form which is 0.xy such that this has m digits and this one has n digits. Then our rational number, sorry, yeah, not this, I would not say the r, we will call it q. in the P by Q form basically will be, you know, xy minus y divided by 10 to the power m plus n minus 10 to the power m. Now please understand, this xy is not a product of x and y. X and y are, you know, the set of digits placed side by side. So x y is not equals to x into y. Okay, these are just x and y placed side by side. X and y placed side by side. So this is the generalization we do. For example, there is a, for example, let us show it by example. Actually, that will be very helpful for you. Say we have a number called 0.123, then 454545. This is becoming repeating. Okay, so what we will call it, 0.12345 bar. So you see there are 3 digits and these are 2 digits. Okay, so what we basically do, we multiply this by first. So we put x, y together. If we put x and y together, x and y together, so what is that? 1, 2, 3, 4, 5. This is the one. This is our xy format. Okay. Minus y. Just the minus, not y, sorry, minus x. I think we have made one mistake here. This is x, not y. Sorry. Minus 1, 2, 3 divided by 10 to the power m plus n. M plus n is 5 minus 10 to the power m, that is 3. So if you see, this comes to be 1, 2, 2, 2, 2 divided by how much? 10 to the power 5 minus 1000. So 99,000. 1 lakh minus 1000. So 99,000. So this is the format. Okay, so you practically get to see that in any rational number which can either be expressed in the form of a terminating decimal or a non-terminating repeating decimal. So any rational number q can be either a terminating decimal or a non-terminating repeating decimal. So on the other hand, the contrary is also true. If you find a, you know, terminating decimal or a non-terminating decimal, it is also a rational number. So this is the end of rational numbers. Now we will go to irrational numbers and then real numbers. Let's make another video for irrational numbers, because anything that goes too long is becomes difficult. One advice I will always, you know, share with you people is that after you check this kind of a video, go to your book, go to your maths book, and you know, solve a few of the given examples without seeing the answers and try to learn from them. Then definitely do the exercises, do the MLQs, all the and the you know, MCQs and um, all the other kind of things that are there. The more you do it, the more the concept becomes very clear to you and it becomes very helpful. As of now we do it like this. Later on we will also do some, you know, quizzes and tests at certain point, but since this is the very beginning, there is no need to go for that. But definitely go to your books. Like if you are in CBSE, then you should be using the doing every problem in the NCRT books, and the RS Agarwal is a very good book, or for that matter any book you you know, follow in your school. Just do the problems. Okay, so there is not much difficulty in any of this. Once you see, now once your concept becomes clear, your funda gets clear, you will be able to solve that. So in the next I think we will need two more videos, or maybe one video, to talk about irrational numbers and the real numbers and some of their properties. So that will change the complete the number system in the arithmetics. Okay, thank you guys. So let's go for the next set now. Thank you.